Welcome to our Chapter 1, Section 3 lesson video, Intro to Trig Functions. We're going to learn about all the different trig functions today and how to find them for certain situations. Alright, so the lesson targets or the learning targets are that we can find all 6 trig functions of given angles, and that we can also find the 6 trig functions of quadrantal angles. Okay, so trigonometry is mathematics dealing with the relationships between sides and angles of a triangle and the relevant functions of any angle. Okay, so given any angle in standard position, we can turn it into a right triangle by extending a vertical line. So we always draw a vertical line to make our triangle from the point P to the terminal side. So our angle right here is this green angle, and we made it into a right triangle by drawing a vertical line down to the x-axis. We always draw a vertical line down to the x-axis. We never draw horizontal to the y. It's always vertical down to the x. That's going to make a right triangle for us. When we do this, we always use some point P to draw that vertical line. We end up with a certain situation. We end up with an x value and a y value at that point. The x value becomes this side of the triangle. The y value becomes this side of the triangle. To get the hypotenuse, it's just a Pythagorean theorem, a x squared plus y squared, take the square root to get r. Okay, so that's what we have right over here. R equals the square root of x squared plus y squared. Okay, now the reason we're using this language is because we can do this anywhere on the graph. But the unique thing that happens is that for all triangles we draw with this vertical line type thing, so I could draw one over here, I could draw one down here, I could draw one over here, the opposite side always ends up being your y value. The adjacent side always ends up being your x value, and the hypotenuse always ends up being that r thing, where r is equal to the square root of x squared plus y squared. Why is this important? Well, we can still do our trig functions, except now instead of opposite, adjacent, and hypotenuse, we're going to use x, y, and r. So just a quick little reminder to yourself, you might want to jot this down somewhere helpful. Y is your opposite, x is your adjacent, and r is your hypotenuse. Those terms are kind of interchangeable at this point. Okay, so the sign of any angle as we go around in a circle is always going to be a y value over our r value. Cosine is always going to be our x value over our r value. And tangent is always going to be our y value over our x value. All right, now that's just the same thing as it was before, because y is opposite, x is adjacent, and r is hypotenuse. So opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Just a different thing for the same idea, but it makes more sense in this context. Well, there's also 3 other trig functions that we need to know. These 3 trig functions are cosecant, secant, and cotangent. All right, well, the way we get these are just the reciprocals. So sine was y over r. Cosecant is its reciprocal, r over y. Cosine was x over r. Secant is its reciprocal, r over x. Tangent is y over x. Cotangent is its reciprocal, x over y. The way I like to think about it is a co is always paired with a non-co. So tangent is with cotangent, cosine is with secant, so one of them is a co, and sine is with cosecant. And they're just reciprocals. So as long as you know the original 3, you'll know that the reciprocal is the new trig function. All right, so let's go ahead and try our problem. So this is what a lot of our problems from the homework tonight are going to look like. It says, given the point 2 comma square root of 5 is on the terminal side of an angle, so that's our terminal side we're going to use right here. This 2 is our x value, and this 5 is our y value. Draw the angle theta and find all 6 trig functions. This draw part is extremely important. You're really going to want to make sure you're drawing your angles for these problems. If you're not, you're going to really mess yourself up. So we draw our angle. Okay, 2 square root 5, those are both positive, so we know we are in quadrant 1 somewhere. So we'll go ahead and draw our initial side there and our terminal side there, and we'll call this the point, 2 square root 5, right about there. All right, so we know that our x value of our triangle is 2, and our y value of our triangle is square root of 5. Okay, so there's our right triangle right there. Now to find our hypotenuse side, we're going to do the kind of modified Pythagorean theorem. So we'll do 2 squared plus the square root of 5 squared, and take the square root of the whole thing. So 2 squared is 4, the square root of 5 squared is 5, 4 plus 5 is 9, the square root of 9 is 3. So that means our hypotenuse right here is 3. All right, so here's our angle theta right here. We can now do our trig functions. So the way you would do this is you're going to do all 6 trig functions. You're going to go ahead and say the sine of our angle theta equals, and then you'll just do SOHCAHTOA from this angle right here. It's always starting at the 0, 0 spot. Remember, sine is now our y value over our r value. So that's root 5 over 3. Cosine of theta is our x value over r value, so that's 2 over 3. And our tangent of theta is our y value over our x value, so that's root 5 over 2. All right, so we did that. We did sine, opposite over hypotenuse, cosine, adjacent over hypotenuse. Remember, our angle we're always looking at is from 0, 0. Tangent is root 5 over 2. The other 3 trig functions, we're just going to look at these answers right here and reciprocate and simplify. Okay, so sine goes with its which is cosecant of theta, and that's 3 over root 5, which we will rationalize to be 3 root 5 over 5. Cosine goes with its reciprocal, which is secant of theta, which is 3 over 2. And tangent goes with its reciprocal, cotangent of theta, which is 2 over root 5, which simplifies to 2 root 5 over 5. So we finished the problem. We drew the angle, we labeled the x, the y, and the r. We found the r using our kind of modified Pythagorean theorem. And then we found the sine, cosine, and tangent, and we reciprocated them to get the cosecant, secant, and cotangent. This is a good chunk of your homework tonight. It looks just like this. You're going to do the problems just the same way I did it here. All right, one thing I just want to note, and this is just a little note I'm making to you guys, it doesn't matter what point we choose on the terminal side, and this is because of what we talked about in our last lesson. These triangles right here, this little one and the big one, they are similar triangles. And since they're similar triangles, the sine, cosine, and tangent and everything for this angle theta is going to be the same. So the trig functions, it doesn't matter which point we choose on the terminal side. They're going to be proportional, so it's all going to work out the same. So as long as it's a point on the terminal side, that's why we don't really care which one we choose. It all kind of works out the same way. All right. One thing I want to talk about is quadrants, what the signs are in each quadrant and how to tell where you are. If I give you a point that is a positive number, comma, a positive number, you know you're in quadrant 1. Your x value is positive and your y value is positive. If I give you a point that is a negative, comma, a positive, you know you're in quadrant 2. Quadrant 3 is a negative, comma, a negative, so both an x and y are now negative. In quadrant 4, our x value is positive, but our y value is negative. Now, because r is the square root of x and y squared, r always ends up being positive. So r is always positive, okay? But our x and y value, they depend on what quadrant we're in. Okay, so as we're doing this, our r value always ends up being positive, just the way it works out, but our x and y value depends on what quadrant we're in. And so we need to keep that in mind. On the example we did on the previous slide, X and Y were both positive, so the answers were positive. But if I'm over in quadrant 2, some of my trig functions are going to be using X, and so they'll end up being negative. Okay, so let's talk about this. It says find the sign of x, y in quadrant 1. Okay, well, let's talk about this. In quadrant 1, that's this quadrant up here, we have a positive comma a positive. All right, well, what does that mean? That means x is a positive number over y is a positive number. A positive over a positive is going to result in a positive. All right, well, find the sign of r over y in quadrant 4. All right, well, let's see, quadrant 4 is down here. That's a positive comma a negative. Okay, so my r value, we said before, our r value is always positive, but in this case, our y value is negative. If I have a positive number over a negative number, my answer is going to be negative. So what this is telling us, if you really think about it, is that x over y, hey, that is cotangent. Cotangent in quadrant 1 is going to be a positive value. Okay, r over y, that is cosecant. Okay, r over y is cosecant. We've had that on the previous side. What is this telling us? In quadrant 4, cosecant is going to be a negative answer. We'll talk about this in our next lesson, but there's a nice easy way to memorize what's positive, which trig functions are positive, and which ones are negative in each quadrant. All right, the last thing I want to talk about, because we've talked about the quadrants, quadrant 1, quadrant 2, quadrant 3, and quadrant 4 so far, but we need to talk about the quadrantal angles. So we start here, this is 0 degrees, 90 degrees is straight up, 180 degrees, 270 degrees, 360, and then each time we keep wrapping around, we can just add 360 to any of those to get the coterminal angles. We call these the quadrantal angles. They're the ones that are on the axis. So each of these, either our x value or our y value, end up being 0, which makes some interesting things happen. And so when we're doing our trig stuff here, we're going to use these values for x, y, and r. I would take a moment, make sure you copy down this picture right here. It's really important. I would probably draw it over and over and over at the top of your paper when you have problems like this. But you're really going to want to know that at 0 degrees, your x value is 1, your y value is 0, and your r value is 1. We just do this because we're using the simplest possible point, 1, 0. So x is 1, y is 0, r is 1. At our quadrantal angles, you'll notice that we always make the r value 1. R is not always 1, but when we do the quadrantals like this, we do make r equal 1. So up here, our x value is now 0, our y value is now 1, and our r is 1 as well. When we go to this side, we've now gone to the left 1, so our x value is negative 1, our y value is 0, and our r value, the distance from the center, is still 1, positive 1. All right, so let's try a couple of these. I'll draw that picture at the top real quick just so we have it for reference. Okay, so this was x is 1, y is 0. This is x is 0, y is 1. This is x is negative 1, y is 0. And this is x is 0, y is negative 1. All right, so we're going to ask ourselves the sine of 90 degrees. All right, so remember the sine of 90 degrees is the y value over the r value. So we're going to go up to 90 degrees right here. We're going to see what our y value is. Our y value is 1. And we said for our quadrantals, we're going to make our r value 1. So 1 over 1 equals 1. Cosine of 270 degrees. So 270 degrees is down here. Okay, cosine is going to be our x value over our r value. Down here at 270 degrees, our x value is 0. Our r value, we said we're going to make 1 for all of these types of quadrantal problems. So 0 over 1 equals 0. So the cosine of 270 is 0. All of these you can check with a calculator, but you got to be able to do these by hand. We're going to have quizzes and tests where you're not allowed to use a calculator. You have to do this part by hand. All right, secant of 180. So secant of 180, we'll look at 180 right here. This is 180 degrees. Secant is cosine's reciprocal. So secant of 180 is going to be our r value over our x value. Okay, our R value we said is 1. Our X value at 180 degrees is -1. 1 over -1 is -1. So the secant of 180 degrees is -1. Check it with a calculator. You have to be able to do these without a calculator, but you can always check your answer with a calculator to be sure. -270 degrees. So that means we start at 0 and we go backwards 3/4 of a turn, and we're doing cotangent. So tangent is y over x, cotangent is x over y. Okay, so our x value at -270, which is the same as 90 degrees, our x value is 0, and our y value is 1. So we do 0 over 1 is 0. Tangent of 450, if we go beyond 360, we can always subtract 360 from that to get back to 0 to 360, so we know what we're talking about a little bit better. So minus 360, that's going to leave us with tangent of 90 degrees. At 90 degrees, we have 0, 1. So we're going to go ahead and write down tangent is the y value over the x value. At 90 degrees, our y value is 1. Our x value is 0, and this is an interesting case, and we'll talk about this a little more in a second. We can't divide by 0, so 1 over 0, we're going to go ahead and say that is undefined. So some of these quadrantals end up being undefined when you have that 0 on bottom. So all of your quadrantals end up having one of a couple answers. They're either going to be 1, they're going to be -1, they're going to be 0, or they're going to be undefined. All right, so let's talk about those undefined ones because it happens at a couple places. Since we cannot have 0 on the denominator, there are a couple trig functions that are undefined only at the quadrantals, so only at 0, 90, 180, 270, and 360, and they're listed right here. Cotangent and cosecant are undefined at 0, 180, and 360. Tangent and secant are undefined at 90 and 270. Real quick, the reason that is cotangent and cosecant, they have a y value on bottom. Okay, so cotangent is x over y, cosecant is r over y. So we cannot have 0 on bottom. So these places, 180 to, or 0, 180, and 360, are where our y value is 0. We can't have our y value 0, so those are where those ones are undefined. Tangent and secant, they are both trig functions with x on bottom. So they can't exist where x is 0. Well, x is 0 up here at 90 and down here at 270. So anytime that x is 0, tangent and secant are undefined, so tangent and secant are undefined at 90 and 270. All right, with that, I think you should have enough information to be able to get started on the homework assignment. I would definitely encourage you to make sure you ask lots of questions when we review a lot of this stuff during our class time, and I'd be glad to help you out with any other questions over Remind or email. I'll see you all in our next live session, and in the meantime, I hope you have a great day.